Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it again and let me show you how I did it. So this is number 1258, Synonymous Sentences. Basically, you have all these sentences and based on this bi-directional relationship, you want to basically construct all the possible sentences based on text. So let's clean this up a little bit and use this example to guide us. I found that very helpful. Let's just do this. Okay, so let's do this. Okay, that is fine. What's going on? Why is the compiler unhappy? Okay, let's get rid of these comments. Okay, cool. So basically, you can see from this graph that this is a bidirectional relationship. So for the reason you can see happy has sad and sorrow because happy maps to joy, joy maps to cheerful, and sad and sorrow are the only other ones that are sort of their own island. So I think it's going to be a little more clear when I actually code it up. So let's just go ahead and make a bidirectional relationship because they're synonymous. And let's call this text.split and let's print cur. Okay, so you can see here that this is kind of our baseline, right? Because happy, the reason this is going to change is because happy is going to be a key that has joy as well. And joy also relates to cheerful. So that's what I was talking about. That's why these are the possible options. And same for sad, right? Because for sad, you can also have for sorrow and sad and sorrow and sad and sorrow. So let's just go ahead and first map this, as I said. So for A, B in synonyms, D of A dot append B and D of B dot append A. Cool. And let's just get all the possible words now. So let's call this set tote.add A, tote.add B. Cool. Just to make our life easier in case we need it. So, all right. So now, basically, let's go over each word in cur. Let's call this C in current. And let's go ahead and print C. And what we need to find is all like the mappings of like any other word that this word can union find into. So basically to do that, let's go ahead and create a DFS D of C and a set and define DFS. Let's call this now and scene. So for word in now, if word is not in our scene, then scene.add word. And if word is in total, and then we have to go through that neighbor. So for example, if we're looking for the happy key, one of the neighbors is supposed to be joy. And then we look for joy as a key, and then we get cheerful. So that whole lake, that's the union find part, right? So for, let's call this neighbor in D of word, then we're just going to run a DFS on D of neighbor and scene. If neighbor is not in scene, then we add neighbor and run the DFS. And then at the end, we just have to return the set back to the function call. So let's print C in value. I think this will make things a little bit more clear. Okay, so also let's say val.discard C because we don't need the original value. Okay, so notice how if we go here, I am is always the case. These are always the case as well because today but was, those don't have neighbors, right? But this, for happy, enjoy, cheerful, this is going to be a three-way sort of thing. And the reason we have 6 rows is because we did 2 times 3, right? So those are going to be the actual lists themselves. So in this case, let's just follow the example. So if value exists, well, if the value doesn't exist, then let's call this everything. Let's go ahead and append just the word, right? Just the word itself. It's always going to be valid in every single sentence. It's always going to be included. Otherwise, we're not going to include the current word, and we're just going to append value because we already have the current word, right? So let's print everything, and we don't want duplicates of the word. Okay, so let's go ahead and see how far we are. Okay, so okay, we actually do not need to discard this because we didn't even include the original word. Okay, here we go. So that's good. So let's actually append a list of value. Because sets are unordered, just makes things a little more complicated. So this is what we're working with, right? So as I was saying, what this means is you have I am cheerful today but was sad yesterday. I am cheerful today but was sorrow yesterday. I am happy today but was sad yesterday. I'm happy today but was sorrow yesterday. So the cross-join Cartesian product of these two are going to be used at the current location. So what that means is let's keep track of the location because now we know what we want to do. And let's call this list index. So for IE, it enumerates everything. So list index.append I. And I'm sure there's a more efficient way to do this, but again, this is the solution that I came up with by myself. It's my own way of doing it. It might be a little messy, but this completely represents my own thought process, which is the point of my channel. So anyways, this is going to keep track of the positions that we need to do that Cartesian product on, right? And then what we can do is now we want to make all the combinations of each of the lists. So basically, let's call this options is list range of, so we just want all the sublists inside of everything. And so to do that, I'm trying to think of how I coded it up. So basically, we're trying to make however many lists we have. So let's call this size is length of list index. And then for I in range size, let's call this options. So options.append. Oh, so for L in list index, right? We're just going to want to append L itself. So let's print options. Just so we get the lists. Okay, that's not right. Oh, so for I, let's just do this. If type of E is equal to list, then we append E. So now what we want to do is do like the Cartesian product, but at the same time, we also want to make sure we keep track of this sort of position. So basically, there is a way to do it for O in okay, so let's just do this for I in range size. We basically just want, for example, if we're just going to say the product, list product of options 0 and options 1. So we just want the Cartesian product. You can see cheerful, sad, cheerful, sorrow. That gives us exactly 6. 1, 2, 3, 4, 5, 6. So that's what we want, but we don't want to hard code this because this could be very long. So for I in range size, let's call this nums is so we want to do product of options instead, except we want to sort of unpack it, right? Okay, there we go. So joy, sad, joy, sorrow, happy, sorrow, cheerful, sad. Awesome. Yeah. So there we go. So now for each of these, remember position 2 and 6, those were the original positions. So this is always going to be index 2, index 6, index 2, index 6, right? So what we're going to do now is go through in range length of current. If I is not inside of list index, then we're just going to want to append. So let's call this result.append current of I. And then for L in list index, so for we want to go through for each whatever you want to call it, for item in A. Now we want to build 6 different lists. So for I in range length cur, if I is not in list index, then let's call this now or TMP. Then we can just append the original word because it's not a list. And then we go over list index. And so we want to print, let's call this the actual bad indexes is just going to be list index. So let's print so we have that index. Let's go ahead and print for this is 2, 6, for example. Let's print item and bad. So we just kind of want to unpack those. Item and bad. That's not correct. So let's get rid of this. So item and bad. For L in list index, let's print L and also item. No, but list index is what? No. So the heck? Okay, list index dot append I, right? That's, I think we messed that up somewhere. Oh, list index enumerates let's get rid of size length list index. Okay, cool. So awesome. So now you can see that we still have that, but we just want to unpack. So let's print bad and also item. So we're just going to insert, right? So for JB and enumerates bad, then TMP dot inserts at B, right? B, we want to insert item of J, right? And let's print TMP. Okay, let's get rid of all this stuff so we don't distract ourselves. All right. I am happy today, but was sad yesterday. I am happy today. Is weird. Huh. It's getting duplicates. Joy today. Perhaps we should have discarded this. No? Let's do this again. Right? And then let's also print cur. So we have I am happy today but was sad yesterday. We're close. Just need to insert them in the right places. I am cheerful today. So, let's print TMP. Yeah, so where is... Let's get rid of this. This is our target. So I am joy today, joy sad. Yep. So I am TMP.insert. Why are we seeing this twice? Joy, sorrow. Let's print temp again. I'm cheerful. Oh, okay, cool. That looks correct. I'm cheerful. No. So, what was... But sorrow was sorrow. Tells me that we need to discard the value itself. No, but it's not. That's weird. I am happy today, but was sad yesterday. Yep. Let's print everything just to see. Make sure I didn't mess anything up. I was happy today, but was, yep, that looks good. Happy. Why are we inserting twice? Oh, so it's not in list index. Right? And then... Oh, range, length, everything, not current, right? Because everything is what we're working with. I am... Cheerful today, but was sorrow. Sorrow was sorrow. I still feel like we're supposed to get rid of this right here. No. What? I am cheerful today, but was sad. What? It's just about placing it in the right place. I am something. Let's print bad and also L. No, bad and also list index. No, but that is what it is. What am I doing? Bad and then whatever words those were, and A, right? Let's call this JL and enumerate list index. Or we can just kind of start over here. Okay, so let's print list index in A. For item in A, let's print item and list index. Yeah, so we want to insert for the current item. So let's call this for t and tmp dot append t. So let's call this unpack is, well, so for JL and enumerates list index, then we can just say copy dot insert at this place. Item of J. Let's print copy. It's too much shit everywhere. I am cheerful today but was sad yesterday. I'm cheerful today but was sorrow yesterday. I am... Okay, that looks correct. Cheerful today but was sad. Let's just compare this. Today but was sad yesterday. Sorrow yesterday. Happy today but was sad yesterday. Happy, sorrow, joy, sad, joy, sorrow. Awesome. So yeah, so now we just have our result. So if copy not if join copy not in result dot append join copy, like that, right? To make a shallow copy, because it's going to get reordered and then we have to sort it. Seems what it looks like. I'm cheerful today but was sad yesterday. Awesome. Cheerful today but was sorrow yesterday. Okay, cool. So let's just return result. Let's run this. Okay, submit it. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.